Hello, my name is Andy Naegle, and today I'm going to present to you my term project, which I call Exposing Covert Channels in Powerline Wiring. My research is focused on a technology known as Powerline Communication, or PLC. PLC is a communication technology that allows for the transmission of network traffic over AC power line wiring found in a home or office building. There are a variety of PLC technologies available. The one I'm focusing on is known as HomePlug. HomePlug is a standard based on IEEE 1901, which allows for the interoperability between different hardware vendors. HomePlug typically functions using small devices that plug into electrical outlets found in a home or office building. They typically feature Ethernet ports and sometimes Wi-Fi hotspots, which allows these HomePlug devices to function as a bridge between two Ethernet networks or nodes. A typical HomePlug setup is to have a HomePlug device plugged into your internet router and then a second device in another room that plugs into your computer. Next, let's talk about some security implications of powerline communication. The focus of my research was to identify a specific threat intrinsic to PLC, which is that it could easily function as a covert channel. Even though some homes and businesses may wish to establish and use their own PLC network, there are probably many more that have no need for this and could actually view the installation as a vulnerability. The idea is that an attacker could infiltrate a corporate network by covertly installing a HomePlug device that could bridge the corporate Ethernet network out onto the power line grid of the building, thus allowing wider exposure of the corporate network. This threat is amplified by the fact that the power line schematics that describe the outline of a power line grid found within a building typically aren't really designed with information security in mind. For instance, you'll oftentimes find electrical outlets on exteriors of the building. This threat is even further compounded by research that indicates that PLC technology is capable of being exploited as an indoor location system. So there's a lot of information that could potentially be breached over a covert PLC network. The focus of my research was to counter this possible threat of a covert channel by implementing an early warning of malicious PLC devices that are installed in a company's powerline grid. The idea is to use a PLC device as a monitor that is installed by the site administrator, which would monitor the power line for the presence of any malicious PLC devices that are installed. In order to build my detection system, I purchased a starter kit from a company called Naegle, which included a set of PLC devices. On the photograph here, you can see that each device features an Ethernet port on the bottom. Also on the bottom of the device, they feature a standard 3-prong electrical plug for plugging into the wall socket. These devices also feature a pass-through electrical plug, so you can plug in an electrical device without sacrificing your wall outlet. So the setup scenario I used for the monitor is to have a monitoring PC connect via Ethernet to a PLC device which will function as a monitor. If anywhere in the building a malicious PLC is installed, the monitoring PLC will notice its presence and it will communicate its presence to the monitoring PC, which will trigger an alarm. In order to develop the monitoring system, I needed to discover how these HomePlug devices communicate. This was accomplished by reverse engineering their communications protocol. The Naegle devices included a configuration software tool that's installed on the PC and communicates over Ethernet to the local PLC for configuration purposes. I basically installed this tool on the monitoring PC, and using Wireshark, I captured the Ethernet frame traffic that was flowing between the PC and PLC. In the process of capturing this data, I discovered that there's a request frame that the PC sends to the PLC. In turn, there's a confirmation frame that the PLC sends back to the PC that indicates the number of HomePlug devices that are found on the powerline grid. It's interesting to note that from these HomePlug frames, they are not TCP or UDP packets that are sent. These are custom Ethernet frames. The next step was to actually create a detection tool based on the information gleaned from the reverse engineering. I actually used a packet generator tool called Colasoft Packet Player that was used to replay the request frame periodically. In my case, every 5 seconds, it would send the request frame to the PLC. And I created a Lua script that uses the Wireshark library to actively monitor for the confirmation frame that is sent back to the PC. The Lua script basically displays an alert where the number of PLC devices found on the power line is shown to be non-zero. You can see in the screenshot here a successful detection of a malicious PLC. So, in conclusion, powerline networks can pose information security threats. And in order to counter some of these threats, early detection is desirable, and I've proven through a working system that detection is possible using some simple off-the-shelf equipment and software as a proof of concept. Ideally, we could extend this to a more commercial-grade system that would send email or SMS alerts. Also, it would be nice if the commercial system had less dependencies and outside libraries and was implemented as a standalone executable. These principles could be expanded beyond HomePlug to possibly include the detection of other PLC technologies. Another idea is to not only offer early detection through monitoring, but to also offer some kind of active jamming or filtering to disrupt any introduction of covert channels. And to take this even further, it would be really nice to see if it would be possible to develop some kind of indoor location system to help identify which electrical outlet the malicious PLC device is plugged into. Thank you for your time.